This will carry more weight after you guys see your grades maybe than it does now. But we're going to talk about metacognition, just real brief, and what metacognition is, and why we should care about it, especially in this area. And so I'm sure, Peyton, you've probably heard about this before, being an education major. And so there's a story of three students, Travis, and this is more than just chemistry, right? And this is why I talk to you guys about it, because it's more than just chemistry. It's actually about all of your classes. And so there's three students. You can see just their test scores, before, and then they learned about this stuff and how to apply this stuff, if you will. And then you can see their test scores afterwards, and you can see there's a marked change. And part of it is because we started to learn, right? And so how do they do it? They become experts in what's known as metacognition, right? It's thinking how you think, right? It's understanding how we think and how we learn, and then applying that to this stuff. And so what ends up happening, and especially in a class like Gen Chem, is we study just for the test, right? So, oh, I know this test is coming up. I have to learn, quote unquote, all this stuff for the test. But then usually, I'll let you guys answer this. Usually what happens after the exam? Does anybody want to answer that question?
Because you know how the questions are asked, basically.
Right. So then what happens, right? So you know the questions, and so you study. You take the test, and then right after you leave the classroom on test day, what usually happens to all that information?
Memory dump.
Memory dump, right? Brain dump. Just it goes. In my classes, there is no dumping, right? And in chemistry and biology and science, it's really hard to dump because a lot of concepts build on each other, especially in this class. And so we need to learn, and so part of this is learning how to learn. And so I want you guys to think about this question, and then we'll have I'll have you guys answer it. What's the difference, if there is any, between studying and learning? Right? What's the difference, if there's any, between studying and learning? And then, maybe based on that answer, for which task would you work harder, to make an A on the test, or to teach the material to the class? So what do you guys think?
If you learn, then you can teach.
Right? If you learn it, then you can teach it.
I feel like studying is more like memorizing stuff, memorizing the answer to a certain question, and not really knowing like why, or understanding why that's the answer. You just memorize that's the answer, so you can make an A on the test.
Yep, absolutely. And so, right, where studying is just, I had a student, when I taught this the first time, give me the greatest answer of the difference between studying and learning. And he said, well, Dr. Bishop, studying has dying in it. And I'm like, sure, it does. It does have dying in it. And a lot of times, unfortunately, that's what studying feels like sometimes. Right. But that's true. Right. It's that base understanding, right, of why. Right. I am annoying to some people because I always ask either why, or I tell them this is why. Right. Because if you don't have the why, then it means nothing. And it's just base information that you just need to memorize. And so it is. We would work harder to teach the material to the class. Now, what I'm not saying is that if you're not good at something that you can't get better, right? Because there are some people who think, well, I'm just no good at this, or I'm no good at that, and so there's no way. No, that's not what we're saying. We're saying, though, that we just maybe have to change a little bit about how we do things. And so when we study, we need to stay in what's known as learn mode, not in study mode, right? Not in, well, I just need to study and cram. Now, of course, I say this, obviously, Gen Chem 1 during the summer is a large amount of information very, very quickly. And so we do kind of have to go into study mode for a little bit. But we do need to study as if you were going to teach the material. And not just trying to make an A on the test. Because I will tell you this, if you study to teach the material, you will probably make an A on the test. It just happens that way. And so, so what does that look like, right? What does this look like? Obviously, we don't have really choice in the top part where we start the problems early. Do not flip back to see the example problems. And I think I told you guys this at the first day, it will be better if I were to give you guys a problem and you were to get rid of all your notes and get rid of all, my lectures and stuff. And then you just try to solve the problem and you try, and whether you finish or not, the point is that you tried. And then in areas where you kind of stop, right, where you kind of get stuck, then you can go back and look and say, oh yeah, that's how I do it. And then you can attack the problem again the same way, right? And don't give up too soon, right? Take about 10 to 15 minutes to do it, but don't spend too much time, right? You can sit there for an hour looking at something and there's nothing really getting done. And so, homework is important. The problems are important. And so let's become an expert in learning. And so what we're going to do is we're going to have a little bit of a practice thing. If you have a pen and paper, that would be nice. Maybe actually you don't really need it now that I'm thinking about it for this activity. But what we're going to do is we're going to think about how we think. And we're going to, realize what being a problem solver is, just how we think, right? That's what metacognition is thinking how we think, and being aware of the type of learning that we're doing and actually how we're going about the learning. And so I want you guys to take part in this. And so you guys will have 45 seconds and I have a timer right here. So you guys will have 45 seconds. I'm going to show you a slide. And here's what I want you to do is I want you to count all of the vowels in the words. Okay. So in the next slide, I'm going to show you a list of words and in 45 seconds, I'll go to the next slide. But I want you guys to count all of the vowels in the words. Are you guys ready? All right, here we go. So go ahead and count all of the vowels in the words. You guys have 5 seconds left. All right. How many vowels did you guys get?
49.
49?
50.
50? All right, now I'm going to ask you a question. How many words do you remember or phrases? Tricky. Oh, Dr. Bishop, you got me. Right? And so this is the idea of metacognition, right? This is the idea of the difference between studying and learning, right? Is that we become so focused sometimes on the small little details, or we just become so focused on one little thing, we get tunnel vision, and so we're not able to grasp the bigger picture. And so this will help us in everything that we do. And so this is why I don't really like the minute details of things. I like the broader patterns, the broader pictures, because they help us learn a lot more than anything else. And so we're going to look at the list again. And so I want you guys to think about this time. Let's think about how they're arranged. right? So we originally were counting the vowels. Now I want you to think about how the words are arranged. And for the same amount of time, you have 45 seconds. All right, 5 seconds left. All right. So now, if I were to ask you, how many words or phrases do you remember? How many do you think you guys could get? Like 5 or so? You'd get a lot more than your first task, right? So then I want to ask you guys then, what were the two major differences between the first attempt and the second attempt? Right? And this is where we kind of get this idea of metacognition and how to study for learning as opposed to study for studying's sake. So the first attempt, I'll tell you, the first attempt, we knew what the task was, right? I gave you a very specific task. You need to memorize the vowels, right? So the very specific, so we can apply this to general chemistry in that you know what the task is. You need to study everything to make an A on the test, right? Very specific task. And so you are focusing in very minute details, trying to study everything out. And then in the end, did you actually learn anything? Or at least you might not know the broader picture. But in the second one, we actually knew how the information was organized, right? We figured out the pattern. What was the pattern, by the way? Did you guys catch it?
It's by number.
It's by number. We'll come back to here, right? So it starts at 1. So dollar bill is 1, dice 2, tricycle has 3 wheels, 4-leaf clover 4. There's 5 fingers on a hand, 6, 7, right? So there are numbers going from 1 to 15. And so we knew how the information was organized. And so one of the things, I don't know if you've ever had this issue. I used to have this issue, and I still do kind of, is you study and you study and you study, and then you get to the test and you see the question and you know you studied it, and then your mind just goes blank. And you think, man, I just studied this, right? That's the difference between task number 1, right? The first time we looked at these words, and then task number 2, right? And so that we're trying to get you guys into the task number 2, right? We're trying to get you into the second attempt, and so that we can actually learn. And so, so a lot of this, is constantly asking yourself why or what if, right? Well, what if he asked this instead of that, right? Why does this happen? And those are great questions to ask. Do think aloud exercises, right? Speak to yourself, talk to yourself. Try to actually teach what you're learning, whether it's, to a stuffed animal, to a couch, to a mirror, right? Just try to verbalize it, right? Because if you can teach it, then you know it. And like what we said earlier, if you teach it, we know it more. And then there's something called Bloom's taxonomy, and it just has to do with, levels of learning and what we know. And, comparing and contrasting, thinking of analogies, thinking of new pathways, right? Thinking about these things that maybe we're not used to thinking about, trying to find those connections. Because once you find a connection, then it's going to cement in your mind a lot more than just learning something by itself. And so that's why so you'll see when we talk about chapter 5 stuff, we're going to bring back concepts from chapter 3, from chapter 4 about, limiting reagents and stoichiometry, but we're always talking about grams to moles or molarity to moles or these things to moles, right? I'm just trying to make those connections so that you can see them. We don't need to talk about really Bloom's taxonomy. So actually, yeah, we do a little bit. So, remembering is the base level, right? That's just memorizing, just rote memorization, right? I give you a list of words, you just memorize them. That's at the bottom level, right? That's the quote unquote easiest thing to do. I had a student ask me once, Dr. Bishop, why can't we just memorize all this stuff? Why can't you just test us over everything we're supposed to memorize? And I was like, because you guys have been memorizing since you were in high school. You guys are good at that stuff, right? And then everything just brain dumps afterwards. And I said, I want to get you guys up higher a little bit. And so then you get understanding, right? And this is where we want to kind of get you to in Gen Chem, where you're comparing and explaining, you're summarizing, you make inferences, applying it as you carry out or using a procedure through executing or implementing, right? So where that question on the exam would have fallen into would probably have been applying, right? Applying what you had learned with a specific set of information and now applying it to a brand new situation. Analyzing, evaluating, creating is just where you just make something new, where you take all of your information and put it together. So in high school, where do you think you needed to operate to make A's or B's? Which section? Yeah, number one, right? That, like, if you could just memorize, you can memorize your way through high school. Well, now, unfortunately, we're in college, and so we have to be moving up, Bloom's taxonomy, and it should be, as you progress from a introductory to a later class, that you do progress higher and higher. So then how do we study? So then this is really the practical stuff. This will be the end of it. How do we study, right? How do we study? And here's how we study. And again, like I said, it's a little bit different, obviously, for our situation because of how much stuff is placed into here. But there is something to be said about previewing before class, right? Especially online too. It's different. To where, before class, before you watch my videos, you should at least look through the book, maybe look through some chapter objectives, look through the problems, just to kind of get our mind thinking about, okay, this is what I should be learning in this section. And then obviously attend class or watch the lectures. And then right as soon as possible, then review your notes to see if there might be something that's missing. With regards to the notes, or if there's something that you immediately have a question over, and then study it. Ask the questions why, how. We talked a little bit about that. This person where we got this from actually kind of puts forth what's known as an intense study session, to where the first couple minutes you have a goal. Okay, by the end of my study, I want to accomplish this, and then you need to study with focus, right? Okay, here's my goal. So to accomplish my goal, I'm going to study my notes. I'm going to reread the chapter. I'm going to do these problems. And then, this is my favorite part, take a break for 10 to 15 minutes, right? Just settle in. Just take your mind off of, do something else. Take your mind off of what you study and then come back to it, right? And then review what you just studied. And it's that downtime where really everything kind of gets set in. They did an analysis where short naps actually help increase learning and help actually people memorize or internalize the data and internalize the stuff a little bit better. And so always solve the problems without looking at an example. We talked about that. That's one way we can better do our study. Memorize everything you're told to memorize. Table 3.4, table 4.1, table 4.2, or 5.1 and 5.2, which are coming up. You don't have to worry about them now. Always ask why, how, and what if questions. Test understanding by giving mini lectures on the concepts. Spend time, each day, and then aim for 100% mastery, not 90%. Right? Because we're not probably going to always be able to get to 100%, but if we aim for 100% and we miss maybe by 5%, we're still at 95%. And that's a good solid A. And so, so this is my spiel that I usually give after the first test. Do you guys have any questions about it? Perfect. Do you guys have any questions about anything else before we end the meeting for today? I have went ahead and published, because I forgot to do it earlier, chapter 4. So chapter 4 stuff is now up. and I am currently working on chapter 5 lectures. I'm almost done with chapter 5, and then we'll finish chapter 6, and then everything will be done for the next. Let me go and stop sharing my screen. Okay. Let me go ahead and just let you guys know that the lab schedule has changed. Just there's just a minor change. Because I was told we could do an in-class lab where we look at math and we look at different type. We can solve different problems in class. And so Monday, June 15th, we will be in the classroom, which means you will not have to wear pants. You will not have to wear long pants or even closed-toed shoes if you don't want. But Monday, June 15th, I put that into an in-class lab, and we just moved all the other labs down a day. And I actually might take out one of those labs. I'm still working on that. But for now, Monday, June 15th, we'll be in the classroom. We won't be in the actual lab, so you don't have to wear regular lab apparel. Do you guys have any questions?